So in 2008, the province of Alberta had 3 area codes, 780, 403, and 587. Telephone numbers in Alberta consist of the area code, followed by a 7-digit number that cannot begin with the digits 0 or 1, and the digits can be repeated. How many different phone numbers are available in the province of Alberta in 2008? So our first blank has how many options? 780, 403, 587. Our second blank says 7-digit number. Cannot begin with a 0 or a 1. So I have 2 to 9, right? Are there any restrictions on anything else? No. This is a nice question. I start off with a 9. So this has 3 options. Times 2 to 9 is how many options? 8. And then I have 10, 10, 10. So it's going to be 24 and 6 zeros. So 24 million. Possibly. I don't know. I think that's the answer. Maybe. Okay. This one is a tricky one. Tricky now. Okay. So this one says each switch on a 4-switch panel can be set to 2 possible positions, on or off. The number of different switch arrangements that are possible if 2 switches must be on and 2 switches must be off. So on is repetition, correct? Off would be a repetition, wouldn't it? Because can you tell, does off, do the off switches look different? No. Do the on switches look different? No. On are both up, off are both down, right? So the way I looked at this is I said, oh, that would be like having on be represented by O and off be represented by F. So that would be like having the word oof, which is maybe how you felt when you looked at this question. So how could I rearrange the word oof? How do you rearrange a word with doubling and tripling letters? On the top you have, how many blanks are there? 4. And then you have how many for the first blank? 4, then 3, then 2, then 1. When you go to rearrange words, if there's no restrictions on the word, like it doesn't have to start with an O or end with an F or start with the vowels must be together, anything like that, you can literally just take how many letters there are and put that on the top, 4 factorial. Remember, this is just like when we did DIR yesterday. Same thing. When we did the DIR with the pathways. And then on the bottom, what do we have to have? Don't all talk at once. 2 factorial, 2 factorial. Why? Why, Alex?
Because there's 2 O's and 2 F's.
Exactly. So we have 24 divided by 4, and I'm going to let you figure out what that is mathematically. It's 6, maybe, possibly. I think it might be right. I don't know. It's your hand in. I'll let you figure it out. And then 3. In a particular family of 8 children, there are 5 boys and 3 girls. This question was legitimately on a diploma, and it makes me laugh. You may not even have laughed at this question, but this is why you should have laughed at this question. So there are 5 boys and 3 girls. There are 8. A photographer is hired to take a series of family pictures of the children only. For one of the pictures, the photographer will select 2 boys and 1 girl and arrange them in a row. Have anyone been in a big family? Does your parent ever take a picture of just randomly 3 of the 8 children? Like, are these just the top 3? Like, I'd be like, are you? I'd be like, I'm the favorite. I made it on this one picture with 3 children of the 8. Like, who does that? Like, this is a stretch. Really? Like, you know what? I'm going to pick 2 boys and 1 girl out of you. Let's see how many ways I can arrange you. Like, randomly, and random. It's like, the question works. But, like, I don't know anyone who takes pictures of 3 of 8 children. Like, I would have a complex. There's 4 of us in my family. I'd be like, you left me out? Like, why am I not cool? Except I'd be in, because it has to be 1 girl, and I'm the only girl, and I have 3 brothers. So one of them's out. Sucks to be that supreme being here, right? But, like, such a strange question. You probably didn't think that. You're probably like, oh, he's easy to do, but it's a really weird question. I laughed at it when I saw it on the poem. Okay, so the number of different arrangements of these 3 children. So we need 2 boys and 1 girl. Does it say at least 2 boys or anything like that? No, so this is a nice question. It's not a standard of excellence at all. We'll go straight for it. We need exactly 2 girls, 2 boys, not girls, 2 boys and 1 girl, right? So if I need 2 boys and 1 girl, how can I guarantee getting a boy? Choosing for a boy. Now we have to decide, is this a C or a P? I literally did these 3 questions because this is a hard question. It's neither a C nor a P, it's both. Because the only way, this is like that smile and frog question I talked to you about. The only way that you can do this is you have to choose the boys first, randomly, right? You have to choose the girl next randomly, and then you have to arrange them. So this is one of those where I told you, do they have any specific jobs in here? Did they give them any specific jobs? No. So it's a combination, and then they ask you to arrange it. So it's a permutation. Okay? So I have to choose the boys first, 8C2. And the reason why it's a C is, do these 2 boys have any certain order? No. And then, that's not 8. There's 8 children. Come on, Lepp, grab a mitt. Okay. 5 boys, and he's going to multiply 3 girls. 3 choose 1, right? If I put P's, this is why P doesn't work. If I put a P, I'm just arranging the 2 boys around, and this girl just sits at the back. She's never getting, actually, put in the middle. They probably put a boy and a girl in the middle, right? That's never going to happen if you pick P's. If you pick P's, there's never a girl in the middle. Because you're just arranging the 2 boys and then the girl over here. Okay? Is that what we want? No, we want to pick 2 boys, we want to pick a girl, and then we'd be done, except they said, it's a picture, we're going to arrange them now. So now we have 3 people, right? So now we have to multiply by arranging those 3 people, correct? So how many people could be in this blank, now that I have these 3 people? 3, you're right, good job, nice answer. And how many could be in this blank? 2, and then 1. So many things going wrong right now. Delete. Thank you. I would have just pressed 6 was mine. Possibly that's the answer. I don't know. It's an option. Maybe. Yeah.
Couldn't you have just treated it like communication by setting them, just setting up the fundamental accounting and doing 5 and 4 for the boys, 3 for the one that's the girl, and then timing it by 3 because the girl can go in any one position.
That is a unique way to do it, and no one ever thinks of it, and it would work in that way only because you're moving the girl around. And it only really works really well because it's one girl being embedded throughout. So that was the same as yesterday when we did 2-1 for the 2 groups in the movie theater, 2-1 for the other 2 groups in the movie theater, and then 1. And then we dispersed them because it was a nice amount of groups. Same thing works here because you have the 2 boy and the 1 girl dispersing. But yeah. Oh, I circled it. It could be that. I don't know. Options. Okay. Those are the 2 of the hardest ones on there, so I just kind of wanted to hit them up. I don't know, maybe let you see them. Okay? Because people usually do them half right, but not fully right. Okay? Most people do this and this and then forget to arrange them. Or they full out make them P's. Which you can't make them be P's because then you would just be arranging the boys and the girl, right? You'd still have to deal with how you'd move them around. Okay? Alright. Notes. Where are we? We are here. Binomial theorem. We're going to go to example 1. And we're not going to do example 1 fully because it's going to not be fun. I really want to say suck. It's going to suck. It's going to be crappy. It's not going to be good. And I will be willing to put that on podcast because it's not fun. Okay? So, 3a minus 2 to the 4, what does that mean you have to do? 3a minus 2 times 3a minus 2 times 3a minus 2 times 3a minus 2, right? We weren't even this meet in grade 10 when we had to distribute. We were taught how to FOIL. Now this is to the 4. What if it's to the 8 or the 10, which is going to be later? That would be awful, right? You have to turn your paper sideways and you still won't have enough room. If you're turning your paper sideways and you don't have enough room, think there must be a better way. Like, don't do that, okay? For this one, tickle. We have to FOIL those, and we'd have to FOIL these, right? And then what would we have to do? Distribute the FOILs. And then we'd have to collect like terms. And then we'd have to hope we didn't make a mistake somewhere in there. Right? Do you think that's the best way to go about it? No. So when I give you the binomial theorem, and you think it's long and arduous and annoying, think, this is worse. Okay? That's the only reason why I'm giving you this example. To make you think, wow, that would really not be fun. Right? And then when I give you the binomial theorem, you're like, this is too long. Think, no, wait, it could be worse. Right? It could be worse. We agree? We're on that same page? We're not having you whining at all? Because, man, this is to the 4. What if it's to the 10? I would for sure make a mistake with 10. Mistakes throughout it somewhere. Okay? All right. So, the binomial theorem. Here this lovely little ditty is. See? That seems overwhelming at this one, but then you remember how we had to do on the previous page, and it's not overwhelming. It's just fine. It's perfectly okay. So the binomial theorem, since it takes quite a while to expand a binomial, the binomial theorem gives us a shortcut in order to come up with any one term without finding all the terms. So the great thing about binomial theorem is if I need the third term, I can find it like that. Third term in descending order. I don't actually have to like expand the whole thing out, collect like terms, put them in descending order, and find the third one. Okay? Which is fantastic. All right? It says on here, one second, I need a mask because I'm going to go in front of Megan and you don't want to sit. It says on here, here's the binomial theorem. It says, in the expansion x plus y to the n on the formula sheet, written in descending powers of x. So it was like the x to the 4 and then x to the 3. It's always in descending powers. So when on the diploma it asks you for the third term in descending order, don't let the descending order throw you off. They have to put in descending order because then that means the binomial theorem actually works. If not, it could be in ascending order and you'd have to flip everything around and the binomial theorem would be opposite, right? So when they say in descending powers of x, they're literally saying that on the diploma so that you can use the binomial theorem. So I have people who freak out about that. That's awesome. You need that so that even though the binomial theorem, you can use it. Okay? The binomial theorem is this, and I'll write it in bigger because it looks really tiny. It's t k plus 1. And you use this t blah, whatever, in your very first unit in 20-1 when you did sequences and series. So if you had T3, that meant term 3, right? If you had T4, that meant you're finding term 4. If it was T6, that meant you were finding term 6, right? So if I want term 7, that's fine. That just means K is what? 6. That's it. So if you know what term you're finding, you have K immediately because it's one less because the formula tells you that, right? And we learned T7 represents term 7. We learned that last year. It was one of the things you didn't even think to learn because you just knew it when they said it. It was immediately in your head, right? So tk plus 1 equals, and then it's nck x to the n minus k y to the k. So that's the formula you're going to use. Now, we actually, with the binomial that they give us, we have x, we have y, we have n immediately. If they give us a binomial, we have all three of those things. Because it says on your formula sheet, in the form x plus y to the n. It needs to be in that form when they give you the binomial. Then whatever's in this spot here is actually what x is. and you fill it in for all the x's. And then what's in this spot here is what y is, and you fill it in for all the y's. And then what's up here is what n is, and you'll fill it in for the n's. And how do we get the k? Well, they tell us what term it is. If they say term 7, we know k is 6, right? If they told me term 20, k would be 19, because the formula says it's t k plus 1. So I'm looking for term 20, k has to be 19. 19 plus 1 is 1, right? So it's actually all given to you. So let's go through this. We're going to go to the example here first. So say I have find the fourth term. What the heck does that mean? T what? I want the fourth term, it's T4. And that indirectly tells me what? K is 3. So I'm going to write that as well. Right? Boom. I already have one of the variables. This is like the knowns and the unknowns in like physics, right? And you have to state all the variables, and then you can only be missing one to fill into the formula, and then you can solve for that one missing variable. Same thing here. We have n as a variable, k is a variable, x is a variable, y is a variable, and as long as I can fill in for all of those, I'm good. Okay? So, I also know it's in the form x plus y to the n, right? So in this case, x is actually x. Sweet. We fill x in for x. That's awesome. It's not going to stay that way if you look at the lower cases, right? X will be 2x or x will be a, right? But in this case, x is x, y is y, n is 8. Right? Because so it's in the form x plus y to the n. So I'm going to write the formula up here so you can see it. So we're going to fill it in. Tk plus 1 equals n c k x to the n minus k y to the k. If they asked me to find the fourth term and I didn't know binomial theorem, I would have to expand this x plus y, 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 FOIL, 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 distribute, 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 distribute them in again, collect like terms, hope to goodness, put them in descending order, and then hope to goodness I didn't make a mistake, right? That sounds awful, and you're probably going to make a mistake. I would, okay? Because it's awful. So this is just faster. I can now find T4 by filling it into this formula that seems overwhelming right now, but it's not that bad. So I need to find term 4. So I'm going to go term 3 plus 1, because that's what K is, equals, N is 8, C, K is 3, X is X, so it stays the same, N is 8, minus K is 3, Y is Y, K is 3. I'm literally just filling in for all the variables. Does that make sense? So the formula looks overwhelming, but it's really not. Now I'm going to simplify it down though. So T, 3 plus 1 is actually T4. Can you type in your calculator HT3? Help me out. 56. And then we get x to the, what's that? 5. Y to the 3. I'm done. Was that a heck of a lot easier than expanding x plus y out 8 times? Yeah. So if they give you the term, they give you k, right? Because it's always one less. Now, this is the other thing to note. There are always, your k is always one less than the term you're finding, correct? So let's just look at this one where it's n is 8 for now, okay? My term 1, k would equal what? 0 technically, right? Term 2, k would equal 1. Term 3, k would equal 2. Term 4, k would equal 3. Term 5, k would equal 4. Term 6, k would equal 5. Term 7, k would equal 6. Term 8, k would equal 7. Term 9, k would equal 8. you always have to go to when k equals n. K equals 9. That is not true. 9 starts with an n. I don't know actually. K equals n. So if I start when k equals 0, which I have to, because term 1 k has to be 1 less than that, right, which is 0. And I have to go to when k equals the n. How many terms is this going to have? 9. There's always n plus 1 number of terms. And they might even ask you that. There's always n plus 1 number of terms. Okay, if they ask you for the total number of terms here, it would be 9. What would the total number of terms be for 2? 8. What would the total number of terms be for 3? 11, right? It's always one more, because I have to start off when k equals 0, and I have to go to k equals n. So if I start at 0 and go to k equals 10, that's actually 11, right? So it's always one more term. And it makes sense. If you forget, go back to grade 10. If I had x plus y to the 2, or let's make it even x plus 2 to the 2, right? If I expanded that, that's x plus 2 times x plus 2, which gets me x squared plus 4x plus 4. Okay? It had a 2. How many terms did I get? 3, right? So if you forget that the total number of terms is 1 more than n, do a really easy one. Do a FOIL. Do a binomial squared. And then you'll see, oh, right, x plus 2 to the 2 gets me actually 3. Right, the total number of terms is 1 more than the exponent. Okay? You can always go back to easy terms. You don't have to try it on a 9 or something like that. That's just strange. Okay, there's a catch on number 2. So, we want the third term. So we want term 3. What is k equal to? What is k equal to? 2. Because it's always 1 less, right? This is the catch, and this is most often where errors happen on a question like this. I told you that, and the formula says this too, it only works for x plus y to the n. Do you see the plus sign in there? X plus y to the n. So before I actually label this, I'm going to rewrite it. I'm going to put an equal to, not an arrow. That's just stupid. I'm going to put this equals 2x plus negative 5 to the 7. So where's the error? People are going to say y is 5. Y is not 5. Y is actually negative 5, and it makes a difference. Do you think they're going to have it? Do you think them and I are going to have the answer where you use 5 as y instead of negative 5? Yep. And then they'll get picked, and it will be wrong. So there's that little catch. If there's a minus sign in your binomial, that minus sign needs to be bumped to the y, and you need to put a plus sign in the middle. Because the binomial theorem only works when it's x plus y to the n. So I still have my x. My x is going to be filled in as 2x. My y is going to be filled in as negative 5. And my n is going to be filled in as 7. And then I just fill it in as that formula up there, right? So I'm going to go t k plus 1. Well, we know k is 2. So t2 plus 1 equals n, which is 7 c k. K is 2. X is 2x to the 7 minus k. So n minus k. And then y, which is negative 5 to the k. I can get most people here, but then people still error. So let's go through and see if you would have. So it's going to be T3. Term 3, that's good. We wanted term 3. That makes us happy. We actually have the right thing going on. If we're looking for term 3 and here we get like term 5, we're like, nope, K's wrong. Okay? So term 3 equals, what's 7C2? Anyone? 7C2. 100 and what? Okay, this is where the error happens. So I'm going to make that be a 5. People will tell me it's 2x to the 5. This is why grade 10 is so important. Did you know that grade 10 is even more important in some ways than grade 11 for grade 12? All your basic math skills come from grade 10. Exponent laws come from grade 10. Factoring comes from grade 10. Being able to reduce a radical comes from grade 10. Being able to make mixed radicals comes from grade 10. So much stuff from grade 10 is so important because you'll be able to do all your grades. People who didn't do great well in grade 10, they'll do all their grade 12 stuff really well, and then the last step where they have to do some grade 10 math, they make a mistake. So we don't want that, okay? Grade 10 is like, honestly, super important. This is where this error comes from if you mess up in grade 10. The 5 has to go to the 2 and to the x, right? If you're someone who's like, I'm going to forget that, and that's usually 3/4 of you, and it's not because you mean to, it's just a silly error. The 5 has to go to the 2 and to the x. So remember when there is like a term with a number of coefficients in front, that 5 has to go to it as well. So it's going to be 2 to the 5, and 2 to the 5 is what? Thank you. X to the 5. And then -5 to the 2 is 25. Do you want to know what happens on calculators? Because your calculator does order of operations. We agree? So I'm going to show you here. If you go -5 squared, it tells me it's -25, and people will write that. Because your calculator has to do what first? The exponent. Did you know that that negative in front of a 5 is actually a -1 times 5? That's what that is. That negative sign is a -1 times 5, right? So it's going to do the 5 squared, which is 25, and then just plops that -1 in front of it. You are smart. You know that it's positive. You know anything to an even exponent is positive, right? So if you want to make sure, what you have to do is you actually have to go, I want to square -5, right? I don't want to square 5. I want to square -5. So how do I force my calculator to do that? Brackets. Remember, brackets it will always do first because your calculator is BEDMAS driven. So we're going to go -5 squared. Boom, 25. Okay? Remember, your calculator runs on BEDMAS. It always will. And remember, you guys were taught this in grade 9. It would always blow your mind when you get like -5 squared, and then you guys would say it was positive 25 when it was actually negative because it wasn't in a bracket when getting squared. It did that. All right. Where are we? So it's positive 25. And then we have to do this in the end. We have to multiply all of our coefficients. So we get term 3 equals, what's 121 times 32 times 25? 16,800. So it's a little large number. Boom. Thank you, binomial theorem. I didn't have to expand 8 terms out, right? Because if it's to the n is 7, that's actually 8 terms that I would get. I didn't have to expand out 7 2x minus 5s. Thank you, binomial theorem. I don't know who came up with this. I should Google it because I really appreciate them. They deserve. Well, Pascal came up with the triangle. Maybe he came up with binomial theorem too. Pascal's triangle led to it leads to the coefficients. Yeah. I don't know. They need a pat on the back. You need to go back in time and give them a rose or something, you know? Like a ribbon. If they have trophy or something. Okay. This one says find the middle term. So it makes it a little harder because it's not specifically telling you which term to find. But you guys are smart. You know that if this is n10, how many terms do I have? 11, right? Always one more. So I'm just going to draw them out because I'm cool like that. I'm going to go term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8, term 9, term 10, term 11. All right? And then I'm going to go, I want the middle one. Slash, 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 slash. Ooh, the middle one is term 6. So what did they indirectly ask you to find? Term 6. That's it. Because you know there's 11 terms. So where's the only time, what does n have to be in order to get a middle term? Even. N has to be even to get a middle term because n is not the number of terms. N is one less, right? So if I take n and I add 1 to it, I get not a number of terms and I can get a middle term. Did you know that they can just ask a question like that? They can ask you a question on determine what n has to be in order to have a middle term? Or describe what n would have to be in order to have a middle term? Could you describe it? It's not always just solving, right? Describe, explain, compare. We need to be able to do all those words the whole time, right? Okay. So, we're going to find term 6. Finding term 6 means k is what? K is 5. X is A, Y is B, N is 10, and we get 10, oh, 2, I don't know why I didn't start with T. T, 5 plus 1 equals 10, C, 5, A to the 10 minus 5, B to the 5. So term 6 equals, what's 10C5? Thank you. 252, A to the 5, B to the 5. Boom. I have my middle term. Right? Now these are the nicest they could ask you. We're going to go get our textbooks, and then when we come back, we're going to do the normal time record. All right. So we need a term with y to the 5. So this is different than the other ones, because the other ones all give you what term you were finding, right? Now they're just giving you a bit of information. When they give you a binomial, they always give you x, they give you y, they give you n, and then finding out what term you need gives you k, correct? So in this case, I'm not given k instantly, so I have to find it in a different way. So let's go through. So I'm going to first rewrite this as 5 plus negative 2y to the 8. This is my x, this is my y, this is my n. K to be determined, because we don't know right now. And we don't know what k is. I put a box in for k, and then I fill in the box later. I just leave a little box. So I'm going to fill into the formula. I'm going to go t box plus 1 equals x, which is 5, to the 8 minus box. And then negative 2y to the box. Once I lay it out that way, it's a lot easier to determine what k should be. What might you think k should be? I need a y to the 5. Where's the only place I have a y? In the second bracket. It's a y to the 1. So what would the box need to be? 5. So I actually just found out what k is. K is 5. So this is 5, this is 5, this is 5. And what did they indirectly make me find? Term 6. Oh, why did I forget the NCK part, people? No one stops me. Just let me skip that part. I would have done the whole thing and no one would say anything. 8C blank, which is 5. So what's 8C5? Did anyone hear that? 56. Or Stephen has to answer everything. And then 5 to the 3 is 125. And we have to remember to do negative 2 to the 5 and y to the 5. Negative 2 to the 5 is negative 32, I believe. Y to the 5. So term 6 equals, now I need to multiply all of these, the coefficients together. 56 times 125 times negative 32. Kaya, did you get it?
I got a negative 274,000.
Y to the 5. Do we agree? So if they ask me what term number has y to the 5, you tell me term 6. If they ask me what is the term, which is what they did this time, the term is negative 224,000 y5. Okay? Flip over. It's the last lesson of the unit, just so you know. Okay, building you up. So this one says the constant term. Constant terms have, do you remember? What is a constant term? If I have 2x plus 6, and I fill something in for x, the 2x changes, right? So if I have like 2x plus 6, and I fill 3 in for x, 2x would turn to a 6, but the plus 6 would stay the same, right? It would remain constant. It would not change. The constant is the one without a variable. The term without a variable. So, the first thing we're going to have to do is what? Before we're going to attempt this.
Add like 2x plus negative over x squared.
Exactly. So we need to put a plus sign in here and make the negative go with the term. So you can just show it that way as well, because you have to have a plus in between them, right? Now we have x gets replaced with 2x, y gets replaced with that lovely thing, and n gets replaced with this. Once again, we don't know k. When we don't know k, we're going to put boxes, right? Every single time. So we're going to go p box plus 1 equals 2x. Why do I keep forgetting the c part? It's like an addiction. It's a bad addiction. I need to stop having it. 15c box 2x to the 15 minus box, and then negative 1 over x squared. Now, instead of writing it like that, what can I write it as? X to the, if I bring that x squared up, it's x to the what? Negative 2. Once again, a grade 10 rule, right? It's always grade 10 rules that differ. So x squared moving up is x to the negative 2. So I can actually write this as negative 1 x to the negative 2 to the box. Now, I need the variable to go away, right? So this is a positive variable on x. This is a negative variable on x. If I make them the exact same, they cancel each other off, don't they? Because when you have bases that are the same, you add exponents. So this is grade 10 again. If I had x to the 3 times x to the negative 3, what would I get? X to the 0. And what's x to the 0? What's anything to the power of 0? Just a 1, right? If I had x to the 3 to the negative 3, that's actually x to the negative 9. Totally different. That's going to be multiplied. So when we have two bases that are the same, we actually add the exponents. So if we want that variable to go away, we need to make them be the same, because one of them is positive and one of them is negative. If they're the same, they become 0, and it turns into a 1, and the variable goes away, right? Okay, so we can do a little trial and error. So say I'm just going to do this, don't do this. Don't write these down, but I'm just showing you. So say I pick 0 for k. I'm only going to put in these boxes. That would become x to the 15, and this would become x to the 0, which is 1. Did they cancel? No, that's a stupid one to pick. So then say I pick 1. X to the 14, x to the negative 2. Did they cancel? 14 and negative 2? No. 2 would be x to the 13, x to the negative 4. Did they cancel? Nope. So I pick 3. This would be x to the 12 and x to the negative 6. We're getting closer, but they're still not perfectly canceling off. So I do 4. X to the 11, x to the negative 8. Nope. Say I pick 5. X to the 10, x to the negative 10. We found k. So I just start 0, 1, 2, 3, 4, 5. You can do it in an order and then figure it out that way if you want. Or you can just use and be like, what would I fill into here to make them be the same? But it's going to be 5. So for every box, I'm going to put a 5. So I'm actually finding term 6. What's 15C5? Megan?
3,000.
Bless you. Then 15 minus 5 is actually a 10. And what do I have to remember to do with that 10? Put it to the 2 and put it to the x. What's 2 to the 10? Sorry?
1,024.
Thank you. 1024 x to the 10. And the 5 has to go to the -1 as well. Now, it wouldn't change anything because -1 to the 5 is actually -1. But -1 to the 4 is actually +1. So you have to watch, because if it's even, it'll take away that negative sign, and they'll have the negative sign answer still be there, which would be wrong. In this case, it's right because it's to the 5. But it's going to be -1, because -1 to the 5 is -1, x to the -10. What happens to these two? They cancel off, because x to the 10 times x to the -10 is x to the 0, which is actually 1, which means they go away. And so term 6 equals, what's 3003 times 1024 times -1? Negative something large.
Negative 3,075,070.
And is that a constant term? Is that a term without a variable? Yep. If after you found it, you still have a variable on it, you didn't find the constant term. You found something else. Okay? Because the answer should be just a number. Because a constant is one without a variable. So what have we done so far? We've done ones where I give you what the term is and you find it. That one's easy, right? K is just one less than it. I told you middle. So you take all your terms, expand them out, and find the middle term. I've asked for a constant term. What I haven't done, which I'm going to do right now, is I've always asked you for the answer. Have I not? I've always asked you for the answer. Now what they're going to do is another option is they'll give you the answer and make you find a piece of the binomial. Okay? So here it says, one term in the expansion of this, x plus a to the 10, is this. This is the answer. And they want us to find a. They want us to find out what the heck a actually is in that binomial. Is it 7? Is it 10? Is it 4? Is it 8? Is it 3? We don't know. So let's fill in what we do know. We know x is x. We know y is going to be a. We know n is going to be 10. Do we know k? No. What do we do when we don't know k? We put boxes, right? We fill it all in, and then we see if we can go from there. So we're going to go t blank plus 1 equals 10c blank x to the 10 minus blank, or box, a to the box. Now, until now, we've always found what this equals, right? But they actually gave us the answer, didn't they? In the last one, we said T6 equals this. So we could plug this answer in for T6, couldn't we? So if we're given the answer, we can plug it in for this blue spot right here. So I can go 3,281,250 x4 equals 10c box, x to the 10 minus box, a to the box. Now this is going to, the answer is going to give me some bit of information that will let me get k. All right? Usually you look to the variable. So the variable here is x to the 4. Why wouldn't I look to this? Because this number is something that if they all have coefficients, I can just multiply them to get that big number, right? So it doesn't really give me anything. But this here helps me. I need to have an x to the 4, right? I have a variable in here. It's x to the 10 minus blank. What does the blank need to be in order to get x to the 4? 6. And if this box is 6, then this box is 6, and this box is 6, because they're all k. So we're going to get 3,281,250 x to the 4 equals, what's 10c6? 210? X to the 4, a to the 6. Now both of them have an x to the 4, so I can divide it off, right? It's going to be really tiny here. I'm going to divide by x to the 4. It's going to cancel. I'm going to divide by x to the 4. It's going to cancel. And I'm going to be left with 3,281,250 equals 210 a to the 6. And now we're just solving for a. What do we do? Divide by 210. What does that get us? Something smaller than 2,280,000. You get it? And then we can just go 6. Math. Pick the one with an x. 6th root of 15,625, which is 5. So 6. Math, the one with the x. I take the 6th root, take the 6th root, a equals 5. You can try number 7. This one's nicer because it actually tells you if the 11th term. So what's it telling you k is? 10. But you would have known k is 10 because you have to go raise y to the 10 anyway. So try it out. Okay, for this one, we know k equals 10. We know x is ax. We know y is y. We know n is 13. And we know this is t11 because they actually told us it's the 11th term. So we can go t10 plus 1 equals, I wanted to go without the n again, 13c 10. Ax to the 13 minus 10. Is it 13 on your little paper? It looks really fuzzy to me. Yeah. Okay. And then y to the 10. Now this is t11, so I can fill this in for it. So 2,288, 2,288, x to the 3, y to the 10. What's 13c10? 286. Now this a has to, the 3 has to go to the a2, and that's what people forget. So it's a to the 3, x to the 3, y to the 10. And it makes a difference. So I'm going to have to divide by x to the 3, y to the 10. So that cancels. And I get 2,288 equals 286a cubed. Divide by 286. What is what does this equal? Cube root, a equals 2. So this is your homework, just so you know. With 6, when it asks you to expand like a whole binomial, we've only ever found like term 3 or term 7 or term 8. If they want you to use binomial theorem to expand the whole thing, if I gave you like ta plus 6 to the 3, let's say, you're going to have to expand it like this being x, this being y, this being a. So you're going to have to go actually and do term 1 first. So you're going to have to go NC0, 2a to the 3 minus 0, 6 to the 0, plus, then you need to get the next term. That's because this is just term 0, right? Or term 1, which is k equals 0. Then you have to do term 2, which is 3c1, 2a to the 3 minus 1, 6 to the 1. So that's term 2. Then term 3, 3c2, 2a to the 3 minus 2, 6 to the 2. And then term 4, 3c3. Like, you're going to stop once you hit these, right? 2a to the 3 minus 3, 6 to the 3. And then you'd have to simplify them all, and you'd get your 4 terms. So if they actually ask you to expand the whole thing by the binomial theorem, you'd have to find term 1, term 2, term 3, term 4, and I stop at term 4. Why did I put an A there? That's just strange. I have to stop at term 4 because it's always one more than the number, right? Than n. So you start at 0 and you go till n. And you have to keep going, right? You wouldn't just stop here. That's for number 6. So please make sure you scrape out all the rest. I don't want you to do them. This is your assignment for tonight. So on Friday, you have the 534 assignment and 542 that you're going to have to post. That's it. 2 assignments. When you go into that assignment post, you'll see I state what assignments need to be posted there. So it'll say 534 in the numbers that involved, and they'll say 542. I'm going to add that right away here. And they'll say the numbers involved, and that's what I need to see. So I always have the assignments listed there that I need you to do for me. Okay? And I think I changed the due date, but I'll go back and change it anyways to the hand-in assignment for Monday. So on Friday, I don't want the, we're going to do a new lesson on Friday. I'm not going to give you homework to it though, so it's just going to be those 2 that have to be handed in Friday. Okay?